My name is Bennett Sandler. I'm the campaign director for HeatSmart Mohawk Valley. We're a project of the Otsego County Conservation Association and the Mohawk Valley Economic Development District. I actually came to the HeatSmart program as a contractor doing residential energy audits and insulation and air sealing projects, and actually worked doing upgrades to the incorporating heat pumps, air and ground source heat pumps into residential and small commercial buildings. Did that for about 10 years before I stepped into my role with HeatSmart Mohawk Valley. Lindsay, maybe you want to introduce yourself?
So hi, I'm Lindsay Spear. I'm the Director of Community Programs for Alliance for a Green Economy, and we're partnered with the Central New York Regional Planning and Development Board to run the HeatSmart CNY campaign. We cover the 5 counties of Central New York, Oswego, Onondaga. I've had Bennett's things in my head all of a sudden, and now I'm something on my own. All right, so it's Oswego, Cayuga, Cortland, Madison, and Onondaga counties. And yeah, so I came to the HeatSmart campaigns actually from a environmental law and policy background. I've been working on a whole variety of different environmental issues in New York State for about 15 years. And came into this program with mostly a background of my own life of hard knocks, do-it-yourself renovations to guide me in this. But have a lot of experience now with learning about heat pumps and insulation. I'm happy to be here to help teach you.
Great, thanks, Lindsay. So as I hope is apparent from this map, Lindsay and I are the operators or campaign managers for 2 of the myriad community campaigns that you see illuminated in this map across New York State. These are all NYSERDA funded outreach campaigns. They're explicitly designed to do these kinds of events. We used to do them in person. During COVID, we've gone to virtual meeting spaces. The whole objective is to present the information we're going to give you tonight and in some several subsequent events over the coming months, focused on clean energy, beneficial electrification. We're going to cover some of the technology. We'll cover some of the context for thinking about switching off of fossil fuels and onto electric-based heat pump systems. In subsequent presentations, we'll present detailed case studies. We've got some in tonight's presentation, but we'll get into those in more detail. We'll present in more detail a list of incentives that are available to you as an individual building owner to electrify your buildings. And then we also expect to lead a home tour, which should principally focus on Maggie's home and her conversion to an air source heat pump whole house system. So we're excited to be in a position to help guide all of you in the pathway to understanding what these technologies are, why they're better than what we have, and how they can actually help reduce greenhouse gas emissions. And with that, let's get started.
So we're going to do a basic overview of why heat pumps are important at this time and why everyone's talking about them. Talk a little bit about home performance improvements as a baseline for before we even do heat pump upgrades. Talk about the different kinds of heat pump technologies and some of the grants and rebates and tax credits available, and we'll do a deep dive into some of the examples. Next slide. Yep, there we go. So we are all using pretty antiquated technology at this point for heating and cooling our homes, particularly the heating. Some of us are using systems and energy types that were installed over 100 years ago or more. Most of us have more modern systems, but it's still based on the technologies of the last century. We have the opportunity as we address climate change to also address a lot of the issues with our home heating systems. This is an opportunity for us to upgrade our home significantly. One of the reasons heat pumps are great is because it saves a lot of money compared to oil and propane and resistant electric systems. It can increase the home comfort significantly. And of course, with no combustion in the home from a fossil fuel furnace of some sort. You don't have the carbon monoxide pollution or other air pollution, which actually is part of the, that can contribute to asthma and other issues that we have with our respiratory system. There's also some advanced air filtration available through a number of the heat pump systems. And knowing some of the audience who's joined us tonight, want to highlight the climate reasons for going with heat pumps at this point, because this is a key part of how we reduce our greenhouse gas emissions. So New York State Department of Environmental Conservation put together this great little slide about where our main sources of greenhouse gas emissions in New York State are. Clearly, transportation is a big piece of it, but so are buildings. And there's no way to really address that other than going house by house, building by building, and really dramatically upgrading our systems. So one of the things we are going to do with that is, of course, heat pumps. New York State, thankfully, has some of the strongest climate goals in the country, and it's actually written into law at this point with the Climate Leadership and Community Protection Act that was passed 2 years ago. New York State has a goal of getting to 85% reduction in greenhouse gas emissions by 2050. And the key piece, subsection of that for getting to that in the building sector, they set a temporary, short-term target of 185 trillion BTU reduction in end-use savings in the buildings and industrial sector by 2025. And so when you really break down those numbers, you're talking about, switching a lot of homes. They're talking about 1.8 million New York homes. It's a big, big number. It's not just homes. We're not just talking about, single family. We're talking about some of the large apartment buildings. We're talking about all the buildings in New York State and how do we decarbonize those systems. Next slide.
Sorry, Lindsay, there's this weird delay that when I actually, whoop.
There we go. Okay. Oop.
It's a single mouse click and it acts weird. Sorry.
Okay. So the key concept to think about here is beneficial electrification. And basically, the people who have been doing all the energy number crunching out there have been looking deep into our systems, thinking, how do we really reduce our usage? Have come to the conclusion that the way to do that is to basically electrify everything. When we have our fossil fuel combustion systems, they are always going to be polluting as they burn. So just by switching to electricity, that reduces that amount of emissions to begin with. And then the other piece is, we keep getting more and more renewables on the grid. In upstate New York, half of our electricity comes from renewable energy at this point. And as more and more renewables come online, the greener the grid gets. So everything that's attached to the grid, so the electric vehicles we've been talking about, heat pumps, everything that's run by electricity will get greener, more efficient over time as the grid gets greener. And so that's why heat pumps are a key piece of this. But what the heck's a heat pump? We'll get into that.
So we didn't do the usual Zoom formalities at the beginning. We are taking questions. Please feel free to put them in the chat or the Q&A. I think that we'll take moments as we move through the presentation to respond to them. Although some of the questions that I've seen so far will likely be answered as we move through the presentation. So I'll address the ones that I've seen in there in short order as we chat about some of these technologies and heat pumps and how they work. So this is likely a well-educated crowd who already knows how heat pumps work. So I won't belabor that too much, but we can certainly respond to questions if folks want to chat a little bit more. I would
make the assumption, let's talk about how heat pumps work.
Sure. No, that's fine. What I wanted to just point out is what's listed here. When we talk about clean heating and cooling, we're talking about a variety of mechanical systems, but also the energy you don't consume by adding insulation and air sealing the holes in your house. So the cheapest form of energy savings, really the lowest hanging fruit, is buttoning up your house and making it more energy efficient. So that's there's sort of a newer term that folks refer to right now in these days, where we call that actually getting your home heat pump ready. You really don't want to pay for an extra large heat pump because your house is inefficient. So we'll talk a bit about energy audits and what you can do to insulate and air seal prior to actually having a heat pump system spec'd out and hopefully installed in your house. I do want to touch on, I'm not going to spend much time chatting about biomass. I know it came up in the Q&A, but there are statewide incentives for biomass systems, including pellet stoves, wood gasification boilers, and pellet boilers. Happy to have a follow-up conversation with anyone who's interested in these technologies, but we're mostly going to focus on heat pumps. Heat pumps themselves come in two main flavors. We've got air source heat pumps, and we're specifically talking about cold climate air source heat pumps, not the more traditionally known heat pumps of the 70s and 80s. And then we're talking about ground source heat pumps. And essentially they're the same technology, they're just different flavors. And as their names suggest, they gather or reject heat for building, heating, or cooling from either the air or the ground. And we'll chat a little bit more about the differences in those two systems. We'll also cover actually heat pump domestic hot water heaters. And there is a third variant to the space conditioning heat pump known as an air to water heat pump. We're not really going to cover that. It's not currently an incentivized technology, but just know that it does exist. So heat pumps, I'm going to take a second here. If you think this is new technology, you'd kind of be wrong. You all have a heat pump in your house already. A refrigerator or freezer is actually the exact same technology, and it uses the physical properties of refrigerant to actually move energy. And so you have refrigerant that can absorb energy at very low temperatures. You can phase change refrigerant of R410A from a liquid to a gas. You can boil R410A at minus 55 degrees Fahrenheit. And because of those physical properties, you can absorb energy in very cold temperatures, a la an air source heat pump. You can compress that vapor and then release the pressure, and you can pull out essentially usable heat that can be made available through the distribution system into your building. The other wonderful thing about heat pumps, and we'll talk a lot about comfort over the next few minutes, is that they turn right around using a reversing valve and provide extremely energy efficient cooling. And so, historically upstate, people haven't felt compelled to install central AC. That's been changing, and we find it hotter and more humid in upstate New York, and folks are less comfortable. And so the ability to turn on a cooling system that pays for itself in the heating season is a great advantage. Ground source heat pumps, again, same type of technology. We'll get into some of the differences shortly, but it's extracting or rejecting heat from the ground to make available inside your building. So we'll step through each of those clean heating and cooling technologies. I want to talk about the comprehensive home assessment, which is a confusing term brought to us from our friends at NYSERDA. What we're really talking about here is an energy audit. And really, those energy audits have been free for a long time here in New York, for at least a decade. And so there's no excuse not to have one done at your house. Historically, they've involved a blower door to actually quantify how much air leakage to the outside you have, and to help the auditor identify where leaks in the envelope to the outside are. And there's a lot of building science that goes into a very prescriptive approach that allows the auditor to identify opportunities, as I've said, to add insulation and plug holes where air that you've paid to heat actually finds its way out of the house. We are moving into a new era in terms of the incentives, the statewide incentives. There's a pilot project right now called Comfort Homes. We're lucky that that actually has been available to folks in the central New York region, where it's about to be opened up in the Mohawk Valley region, which includes the counties of Oneida and Herkimer, as well as Otsego, Schoharie, Fulton, and Montgomery. So we're excited about that. That brings some incentives to market rate households. And then for low and medium income households, there are still free energy audits that are available, as well as a host of incentives to follow up and actually do work to button up your house. If it sounds a little confusing because there's 3 different programs, there are 3 different programs, and they're delineated by what your household income is. So one of the first hurdles actually in figuring out what's best to do for you is to figure out which of the 3 categories you fall into based on the number of people and the income. You'll see tables shortly that allow you to begin to determine which bucket you fall into, and then there are individual audit programs within each of these categories and different levels of incentive as identified in this graphic in terms of the amount of incentive available for insulation, air sealing upgrades based on household income. This is really annoying. Sorry, you guys. So, cold climate air source heat pumps. I mentioned before they use the physical properties of refrigerant to harvest low-grade heat from outside and make it available for use for space heating and conditioning, cooling, excuse me. You can see within the cold climate air source heat pump family, we have 2 different varieties. We've got the most common configuration at the top, an outdoor unit connected to an indoor head. There are options beyond the high wall head that you see in the picture, in the top picture here. There are ceiling recessed units, there are floor standing models, and you can actually, in some cases, share through what's called a ducted unit. That's not the whole house system that you see on the bottom. The unit that you see at the top can be configured in such a way that you have multiple heads running off a single outdoor unit. And that's how you might begin to look at conditioning more than a single room. And we'll chat a little bit more about some of the advantages and disadvantages of doing that. The configuration on the bottom is a more traditional air handler unit with a heat exchanger that's really designed as a retrofit for an existing ducted heating and cooling system. So that's more of a direct drop-in replacement for an existing furnace and air conditioning coil. So, benefits and limitations. Cold climate air source heat pumps. It's a little bit confusing sometimes when I tell people that these units operate at some efficiency greater than 100%. I want to take a second to just explain that. We can claim, we can't claim, we know that these systems operated at 150 to 300% efficiency, because they actually gather and move heat. They're not burning a fuel to make heat, or in the case of electric resistance, like electric baseboard or a plug-in heater, it's not using the resistance of the flow of electrons to make heat. And so you can get efficiencies above 100%. Just so you know, a high efficiency propane system, typically they spec out around 95% efficient, which means 95% of the usable heat contained in the fuel is made available for distribution in the house, and 5% is lost through the flue or the stack. And the system efficiency may be lower because of distribution, but you know, that's the cat's meow within the world of fossil fuel. Electric resistance heat, which everyone knows is traditionally the most expensive way to heat, is 100% efficient. And so it's most expensive because of the cost of electricity. So it may sound like mixed messaging to suggest that we want to convert everyone off of fossil fuels to electric-based systems, but it's because of the higher efficiencies of heat pumps that you actually see a reduction in your total energy costs for heating and cooling when you're operating at these higher efficiencies. So what does 150 to 300% efficient mean? It means for every unit of electricity that's used to run the heat pump, it's gathering 1.5 to 3 units of usable heat for the house. And that's why we get these 150 to 300% efficiency ratings for this equipment. These cold climate air source heat pumps work down to very cold temperatures, as I explained. The engineers have figured out how to take advantage of the physical properties of in very cold temperatures of the refrigerant. Most units work down to somewhere between -14 and -18 degrees, some even colder than that. As I mentioned, they do very energy efficient cooling. You do find that there are essentially limits to the capacity of those outdoor units. So if you have a very high load house, you might end up having to put multiple outdoor units in order to serve all of the spaces in the home. But the other thing that I didn't clearly explain, but I want to take a second to point out, is that these mini splits are the cold climate air source heat pumps, the ones that are non-ducted, are often called ductless mini splits. And essentially you remove the need for ductwork if you have these heads to distribute heating and cooling. And the distribution is in insulated refrigerant lines that essentially run on the outside of your house. And so the distribution system is through the refrigerant that runs from the outdoor unit to the inside heads. And as I said, that mostly runs outside. So all of a sudden, you can very easily add comfort to a room that's been impossible to heat with the old heating system. Either it's at the end of a long duct run, or it's at the end of a hydronic radiant loop that's always cold by the time it gets to that room. And so you can add control, you can add zoning control with every head, and you can add a lot of comfort to each home. So these systems are great for really improving rooms that have historically been difficult. If you've never been around one of these pieces of equipment, we strongly encourage folks to lay eyes and ears on them. They're exceptionally quiet. They are not the tornado sounds of the old style heat pumps that you hear in the mid-Atlantic states or the air conditioners. Both the inside heads and the outdoor evaporators are very quiet. And as I mentioned, this is not actually new technology. They've just improved it, right? We've had refrigeration technology for over 80 years. So what are some of the limitations? As I mentioned, these systems are really designed around space conditioning and not necessarily whole house systems. And so you can, in a large load house or a highly complex designed house, find that you got to spend a lot and put a lot of different pieces together in order for the system to work for the whole building. We sometimes get to temperatures colder than -18 degrees. So if you have a relatively high load house, you may want to think about maintaining a backup system that can be electric resistant or potentially your old fossil fuel system. And the other thing to remember is that these appliances have a lifespan of about 15 years, unlike today's furnaces and boilers, which are anywhere from 20 to 25 years typically for a fossil fuel appliance. And that's mostly because part of that system lives outside, so it gets hammered by the elements. And it's likely in 15 years that when either the outdoor unit fails or an inside head fails, because refrigerants evolve, it's likely that the entire system is going to actually have to be swapped out. So there are life cycle costs to be thought about with the adoption of this technology. Ground source, same technology, except instead of using ambient air temperature to boil refrigerant, we're using fluid that's circulated in pipes in the ground. And oftentimes that's fluid that has some antifreeze added to it. There are a variety of configurations for putting pipe in the ground. If you've got the acreage, you can do a horizontal loop system like you see here. It's got to be 6 feet down. If you don't have the acreage, you live in a city or village, vertical wells can be drilled. The loop is inserted into the well itself, and it's surrounded by a paste, a grout that actually allows for better heat flow into the pipe. Those systems are a little bit more expensive, but a higher quality energy source. And then, you have your less common but available pond loops. You can have a heat exchanger dropped in a pond close to your house, or potentially an open loop system based off of an existing well. Ground loops, right? This is what they can look like. You've got some horizontal trenching. This is actually called where you've got the loop-de-loops there. Oh man, senior moment, I'm forgetting what they call that kind of configuration. There's a variety of ways to get the pipe in the ground. It can be trenches like this. It can be a large pit. It can be directional drilling as well. But the unit that ends up in your house looks a lot like sort of a fancy furnace, right? And what you see there is an air handler unit. That's what's called a water to air heat pump. It hooks up to ductwork. It has the heat exchanger and compressor inside. All the refrigeration is contained within that box. There's no distribution by refrigeration. And so that unit can drop in and replace an old furnace, oftentimes with lots of caveats. Oftentimes you need to make some modifications to old ductwork to ensure comfort. But that box connects to the ground loops that go to the outside on one side, and it has ductwork or hot water piping coming out the other side. Benefits. Ground source heat pumps are, because as I've mentioned, the ground is a better source of energy than the air for most of the winter. They are a higher efficiency system. And in some cases dramatically higher. As we mentioned, all heat pumps, space conditioning heat pumps, can do heating and cooling. But when you have a ground source heat pump, you can also extract or make domestic hot water from the ground source heat pump. These systems are not limited in terms of capacity. You can get very large heat pumps or daisy chain them together. They're really designed as a whole house solution. They too are very quiet, exceptionally quiet. If you're wondering about the pipe that goes in the ground, that typically the manufacturers warranty the pipe for 50 years. It's expected to last for 100 years. But perhaps more significantly, the inside heat pump itself has a expected lifespan of about 25 years. And so its life cycle cost is actually, or life cycle is longer than the air source heat pump system. The other thing I just want to point out is because the refrigerant's contained in that single box, when that heat pump eventually needs to be replaced, you simply disconnect the connections to the loop field, and you disconnect to the distribution to the house, whether that's air or hydronic. You pull the box out, you put a new one in, make those connections, and you're off to the races. The downside of ground source heat pump is, if anyone's started looking at pricing, is they're expensive to the tune of, they're typically twice as expensive as an air source heat pump system. They can be even more expensive because of the modifications that need to be made to accommodate for heat pump technology into older homes. They're very, if you're building a new house, it's a whole different story. You can easily design for the lower temperatures from heat pumps. And they're complex systems. So you want to have confidence in your installer that they're doing all of the things that need to be done to ensure comfort and lifespan for the equipment.
So I'm going to talk a little bit about,
Yep.
Yeah. So I'll talk a little bit about heat pump water heaters. So this is sort of the entry-level version of heat pumps, if you will. For those of us who maybe can't go for a whole system at this point, one place where we can do heat pumps are with the water heating systems in our basements.
Sorry.
So I'll keep talking, you keep going back.
Yeah, I have to know not to touch my mouse. Go ahead, sorry.
So the way heat pump water heaters work is they basically have a heat pump sitting on top of your water tank. And so they're electric water heaters, but they're pulling some of the heat from the environment around them. So that would be your basement. The added benefit is they do provide a little bit of dehumidification in the process. So if you have a slightly damp basement, this actually could be a very good benefit for you. So they pull some of the heat from the basement, and you slowly bleed that into the water in your tank. So it heats up the water. They do have modes that will go into basic resistance electric if you're doing a lot of water use all at once. All the family comes to visit and everybody's taking showers back to back. They can handle that. It just will be less efficient. But for the household that's doing the normal water usage, it's it's very efficient. It's about 2.5 times more efficient than an electric water heater. Some considerations, like I said, does make the basement a little bit colder. So if you are both, pulling the old fossil fuel furnace out of your basement and putting in an air source heat pump, you might want to just consider venting. Some of the installers have been venting the air, outside for the cold climate air source, or for the heat pump water heater, just to avoid creating more cold in the basement. But it also, of course, in the summertime, it provides really efficient water heating because you're pulling from the warmer air that's around it. So the units they're a little bit taller than your average water heater, so you do need to have a slightly taller basement. So if you have a very short basement, it'll be hard to put those in. But they also, they're just very efficient. It's great, and they cost a lot less than your average water heating or your average heat pump system. And with a bunch of the rebates that are available right now, they're just basically the same cost or less than a conventional water heater in many cases, particularly if you're in the low to moderate income range.
I'm just gonna, if I can, I'm just gonna point out 2 other things. First of all, you don't want to put one of these in a finished condition basement. Because they will cool the space. So you don't want to pay to heat the space and then pull the heat out to make domestic hot water. So that's another consideration. And in an ideal, well, I shouldn't say you want ideally a wet basement, but these things will also dehumidify the air. So if you happen to have something of a damp basement, or you're running a dehumidifier typically, and especially in the spring and summer, these units will actually do double duty, not only making hot water, but they'll help dehumidify the space as well.
The other thing is you do need adequate airflow around them for them to work well. So if you have your water heater in a closet, it would not be a good fit for you. But for most people with basements, it's a great opportunity. And we've heard from a lot of people who really enjoy theirs. One other thing to know, though, is they're noisier than a water heater. The average gas or electric water heater, it's just sitting there quietly doing its thing. This does have a fan, and so you will hear the fan. Most people that I've been talking to, they say that, they hear it, but then, it's one of those just background noises of your house that you get used to, you don't notice.
So we're going to spend a bit of time chatting about what these systems cost, and how they compare in terms of operational cost savings. But there's a whole bunch of other attributes for heat pumps that make them a better system, as Lindsay was started with. It's a better way of doing things. So we'll make the case that these are most often a cheaper way to heat and cool, heat a space, including natural gas houses. It's just that the value for a natural gas house, the energy savings is not as dramatic as it is for the higher cost fuels. So typically folks are not compelled, unless they're looking for an environmental solution to climate change. They're not typically interested in replacing a gas heating plant before its time is up. But if your equipment is coming to the end of its life, that's a great time, even with natural gas, to look at a whole house heat pump replacement system. I know that was a question in the chat, so I wanted to address that. Heat pumps have no combustion, so there's no worry of flue gases backdrafting into conditioned space. So they're a safer technology. They typically require much less maintenance. Usually it's an issue of replacing filters or cleaning filters. There's no nozzles to clean. There's no annual maintenance that's required. It's usually not a bad idea to have a service tech come the first couple of years just to make sure everything's performing the way it should. And as we've said multiple times, right, this is how we actually solve our greenhouse gas emission problem. We need to get everybody off of fossil fuels and at the same time green the grid. And when we do that, we can dramatically reduce greenhouse gas emissions. So we like to talk about the fact that heat pumps are cheaper, cleaner, safer, smarter. So I'm we're probably running a little long here. I'll try to be brief. This is, in my mind, a really informative slide, and it's actually, right, the annual cost for a given house that uses 850 gallons of fuel oil to heat for the entire season. This is the annual cost to heat that home using a variety of different types of fuel and heating plants, right? So propane and electric baseboard, as we've already said, closely followed by fuel oil systems, are the most expensive. We live in central New York. We all know, whether we did it or not, that wood's the cheapest way to go, but it's not that much better than a heat pump. And so there's a lot less sweat equity required for a heat pump system. So they're often an exciting choice for folks who are looking to transition themselves off of a wood stove. You can see here where pellet and gas fall into that spectrum of costs. Sorry, just wanted to see the point that I like to make is, using these cost structures, a ground source heat pump system operates at close to $2,500 less. This is just for space heating, so $2,500 less than a propane furnace, which means if your total at the end of all the incentives, you had to spend $25,000 for a ground source heat pump system, you'd essentially pay that system off in 10 years in propane savings using that system. So there are some pretty dramatic operational cost savings to be had by switching to heat pumps. So that's lots of times people say, hey, that system looks and sounds great. I'm sorry, Lindsay, do you mind if I got carried away?
Go for it.
I'm jumping into
keep
it.
going.
All right. Okay.
Roll.
So lots of times folks flip out because heat pumps aren't cheap, and so the perception is that it's unaffordable. And we'd like to make the case that actually at the end of the day, there's a reasonable path forward, and most significantly is the availability of utility rebates for whole house heat pump systems. This is a little bit of a confusing slide because, of course, the program is set up to be somewhat confusing, but Suffice it to say that the amount of the rebate is based on the size of the system you have to install. What I do want to point out is that the rebate for ground source heat pump systems is $1,500 per 10,000 BTU, 33% higher than the $1,000 per 10,000 BTU for a whole house air source heat pump system. The other thing that you don't see on this chart that skews, I take that back. There's also federal tax credit funds available, and there's a dramatic difference between air source and ground source heat pumps. So you'll see that ground source, as I've mentioned, ground source heat pumps are a lot more expensive, but the incentives are much higher for that system. And actually, we're mostly focusing on residential. There are some custom rebates when you get into really big buildings, and it's really exciting to hear. And I want to hear Lindsay talk about the affordability grants that HeatSmart Central New York provides in addition to these utility rebates and federal tax credits.
Mm-hmm. Yep, so HeatSmart CNY is one of a number of communities funded by NYSERDA that actually has grants available for low and moderate income households. I'm going to put the caveat on here. We're going to talk about another exciting program in a moment. And while that program is going on, we're generally not offering our affordability grants because the incentives available through the other program are so huge. That said, we are doing the geothermal grants on a case-by-case basis at this time. And so these are for households that would qualify for the Empower or the Assisted Home Performance insulation air sealing programs. And so that's basically 120%, below 120% of area median income currently. It used to be 80% of area median income. And during the COVID crisis, sort of bumped up the eligibility and the amount of the grants available through Assisted Home Performance, which is very exciting. So why don't we go to the next slide? So Heat Pump Demonstration Study is this new program. It's a very short time limited offer right now. New York State is really trying to crack the code on how to help low to moderate income households afford to make the upgrades to heat pumps. Again, because the energy cost savings, on the day-to-day basis are, month to month, year to year, dramatically help those households afford their energy. The challenge is, of course, the upfront costs. And so how do we help those households get over that upfront cost hurdle in a way that allows people to make the switch? So this demonstration study, it's giving, New York State is basically going to do this with 500 homes. There is money available still, but it is going pretty quickly. People need to, either own or rent the home, but you have to have the landlord's permission. It's not for homes currently on natural gas. Again, because the cost savings are pretty close. They really wanted to focus on the households that would really see the energy savings in a very large way. Heating systems have to be older than 5 years old, and the insulation of the house has to be a certain amount of energy efficiency already, or can get to that same level through the Assisted Home Performance or Empower programs to improve the insulation and air sealing. There's a specific number. It's not going to be meaningful to anybody, and I can't remember it off the top of my head either. So I'll let the experts do that piece. And so then the other issue is, do you qualify for Empower or Assisted Home Performance? And we'll look at those numbers on the next slide. Okay, so basically, we're talking about people who make less than 120% of the area median income. That is a huge number of people in New York. So these are the income numbers. So take a look at how many people you have in your household and take a look at that maximum gross annual income. That has to be from all the people in the household. And it's pretty much the same numbers in all counties except for the single person households. And I will note that the numbers for Schoharie County are actually pretty significantly increased over these limits in the other numbers of people as well. But basically, if you have a household of 3 people, and including children, and make less than $96,000 a year, you would qualify for the heat pump demonstration study. Go to the next slide, please. So I want to give a couple of examples and real life case studies. And so this is a house in Janesville, New York, just south of Syracuse. It was primarily heated with wood. They did have some propane as a backup. And they went and installed a geothermal system. So this is what the actual costs were for their household. And this is clearly a big investment in this house, basically taking a 200-year-old house and bringing it into the 21st century. Because they also installed solar, at this point, they are paying for the entirety of their heating and cooling through their solar panels and only pay $20 a month to utility as the connection charge, which is amazing. But there was a fair amount of money invested up front. Some of the rebates have changed. The NYSERDA rebate has now changed to the utility rebates. And Bennett, will you click, please?
Sure.
There we go. So this would be what the system would cost with either the Empower or System Hub performance level of qualifications for the heat pump demonstration study. You can see that even the utility rebates have actually gone up for geothermal, which is nice, just a little bit. And the federal tax credit, of course, is dependent on whether or not you actually have a tax appetite. So if you don't pay taxes because you get the standard rebates and all the deductions and things like that, and so you don't usually owe taxes, you won't be able to take the federal tax credit. It's not a tax rebate, it's a tax credit, unfortunately. So for low and moderate income households, sometimes this is an issue and you can't count on that, which is one of the reasons why there is so much money available to help support those households in the upfront rebates. So you can see here, that's $10,000 basically for a geothermal system, which is amazing. And as I've had with the HeatSmart CNY affordability grant, we are doing on a case-by-case basis, additional $7,500 off. So we will consider those. The other thing with the heat pump demonstration study is that it knocks off some of the costs that are associated with installing heat pumps. Often you'll find houses, particularly a lot of our old houses, need to have their electrical service upgraded. So there's some money involved to help with that cost. Of course, with insulation and air sealing, it's basically a 50% matching grant from NYSERDA or free if you qualify for Empower. And there is some money for ductwork modifications, but it has to be shared with the electrical service upgrade. So if you already use $2,000 for the electrical service upgrade, it's already gone. Next slide.
Did I go too far? Nope, I didn't go far enough.
Yep, keep going. So this is an example of a house in Cuyahoga County that installed a cold climate air source heat pump system. They actually have 2 outdoor units, one's an LG and one's in Mitsubishi, just based on some of the different benefits of each system that they liked better. And so their cost for installing was about $13,000 after rebate, after the original. Okay, this one doesn't show the original cost, which was a little bit more, but it wasn't much more from NYSERDA rebate. This is now the utility rebate, what it would cost now. And hit another click, Bennett. Okay, and with the heat pump demonstration study, the rebates for the heat pump demonstration study for people who are at that 60 to 100%, 20% of area median income, the amount knocked off is another $8,000. And for Empower households, basically the amount that's knocked off was about $17,000 when you ran the calculations. You can't get a negative amount, so it basically comes out to being free. And again, the insulation and air sealing, if it's a system home performance, it's cut in half. If it's Empower, then it's covered up to $10,000 worth of work. So this is an amazing opportunity for people to dramatically upgrade their homes.
The trick, of course, is not only do you have to qualify, but you actually have to, and we're here to help, you have to work with the Empower and assisted home performance contractors, and oftentimes help them navigate a collaboration with a heat pump contractor as well. So there's a little bit of, boy, it just does not want to simply move from one to the next. I'm sorry.
So for the cost that remains, there is a significant financing option available through NYSERDA. It's the Green Jobs Green New York Smart Energy Loan. There's also on-bill financing, which is similar. And a couple of years ago, they went to offering it to not just households with incomes below 120% of area median income, but also to households that fall in an area where the average income is below 120%. Recognizing that there's a number of households where income documentation is really a barrier to actually getting assistance. This is a way of really helping out communities that can use the assistance. So, you know, this is the financing. It's 3.99%. It's 3.49 if you do it as an automatic deduction from your bank account. But it's a great way of financing the system. So you can basically cut your annual, you know, out-of-pocket costs dramatically.
So just very quickly, we were, this is one of the tools that we are putting together at HeatSmart. Mohawk Valley and Central New York are helping folks navigate the myriad of programs, but also connecting with contractors who participate in the utility rebate and NYSERDA funding option. So one thing that we haven't, I think, explicitly said yet is that in order to harvest that utility rebate, in order to take advantage of the financing loans that Lindsay just described, you need to work with a contractor who has signed up with the utility for the former and NYSERDA for the latter. And so there is an active list of contractors who do one or both of those services, and we expect to make this map available. Right now, there are sort of comprehensive lists statewide, but I should back up and say at HeatSmart.CEGA, our approach has actually been to provide sort of here's the list of participating contractors. We can help you shortlist that if you want, but we want you to know that there's a whole bunch of folks out there who are doing this. It's and that's an evolution from, or a shift, I should say, from the way HeatSmart Central New York does things.
Right. So we've actually gone through the process of doing an RFP and vetting a number of local installers and choosing a handful to work with. So, you know, we've gone through the process of checking, you know, the quality of their installations and knowing how they work with people and knowing that they are participating with various programs. So we're trying to make it a little bit simpler in the decision-making process for people.
I do want to say, just as a follow-up to that, that all of the contractors who work with who are signed up with the utilities for the rebate programs are subject to a third-party independent QA/QC program that NYSERDA was managing and has recently handed over as well to the utilities. So anybody that's participating in the program ought to be doing, you know, they're being watched, and there's a pretty rigorous QA/QC follow-up to their work to make sure they're abiding by best practices. So I'm going to skip that one slide about do they work. We wouldn't be here if we didn't think they did. Of course they do. There's a website that NYSERDA maintains that has a list of case studies across New York. As I mentioned, actually at the beginning, we will be organizing and presenting a detailed webinar at one of the subsequent meetings for this group. Trying to read, I don't have the dates right in front of me, but I'm sure before we end, we can post that information out, and I'm sure Maggie will harass everyone. But we'll go through a detailed breakdown of a variety of homes in our region that have run the gambit in terms of system installs, both energy audits and heat pumps, and show you actual real world data on what their energy use was before and after. And with that, we are right at an hour, huh? So here's
I'm
our
happy to stay
contact
on if people have Q&A
information. We can, yep. If you need to go, by all means, but we are here to answer your questions. And if you can't, we can run through the Q&A now. And but here's our contact information. Feel free to follow up with either Lindsay or I, and we can help you through the process or clarify things questions you might have. Maybe we should just start pulling up the.
Yeah, we've been doing a lot of the answering actually as we went, which was great.
Okay.
It's kind of fun, Bennett. You know, while you were busy talking, I was busy answering things.
Oh, good. I was worried about moving the screen, so I stopped trying to check it. Yeah.
That was great. You know, I see a question about savings versus natural gas, which we did answer as we went. And Margaret also talked about her system being, you know, from a natural gas system to air source heat pumps. And let's see, someone asked, what's a high wall head? And I was pointing out the units that we were seeing then. Maggie, can you point out the high wall head unit right behind you?
Yeah, can you actually see my video?
Yep.
Can you see me?
Yep.
You can?
Yep, we can.
Okay.
Surprise.
Can
Yeah,
you
so we can
see
see
it
it.
now? Here, let me turn
Yep.
the light on for you, a little brighter.
Yeah, so that's
There
when
you
they're
go.
talking about high wall head unit, that's what they're talking about, and that's where the heating and cooling comes out of for ductless mini split system.
Okay.
Let's see here.
Can you actually, can the group see it? Because I don't see it on here.
Yeah, we can see it.
Okay.
Let's see here. So Jennifer's asking, is there one in each room? It depends on the layout of your house. You don't have to have one in each room. It depends on the airflow, how often you close off a particular section of the house or not. Some people like having them in their bedroom. Some people prefer not to have them in the bedroom, actually. If you'd like to sleep cold, you actually might want to have it more located in a hallway space that's common to a number of bedrooms. And then, you know, when you want the warmth to get more into your bedroom, you leave the door open. And when you want to sleep cold at night, you close the door. The lower set points on many of these is only about 60 degrees. So if you like sleeping colder than that, that's something to consider. For a lot of houses, particularly ones with open floor plans, you'll see one unit in, you know, a common living space like the living room that provides most of the heat for much of that first floor area, the common living space, you know, just flows around. A contractor, a reputable contractor, will help you figure out what the best system for your house is. And of course, if you have ducts, if you have air ducts, then, you know, you basically are using the air ducts instead. We have a question. I've heard if you button up old homes with insulation, it can create moisture problems. But you want to take that one?
Sure, love to. So there is an interesting probability that when you add insulation to particularly to sidewalls, you can have vapor drive, which can lead to paint failure. You can get rot and mold and mildew. But typically what that is a basement moisture problem that was solved by burning a fossil fuel appliance in your basement. In other words, the house was designed without insulation. It didn't have a robust vapor moisture barrier across the basement floor. And so when insulation was added to the building and air sealing, that the relative humidity in the building, you know, was very high. And then when you go through the seasons, you get a variety effects from that. So the bitter pill that I often found when I was consulting with residential building owners for whom I'd done an energy audit was the fact that before they could do insulation, they really needed to figure out how best to deal with the moisture problem in their basement. And some of that can be mitigated by the choices you make for how the insulation's installed, but most of the time, it's sort of the bitter pill of spending a fair amount of chunk of change just putting in some kind of moisture management regimen, whether that's interior or exterior perimeter drainage, even gutters on the outside of the building that can be simple. It's often not, and so it's just part of the added expense of being able to make a building that more energy efficient and durable by dealing with the things that they didn't concern themselves with when the buildings were built.
I can actually speak to this one from lived experience too. So we renovated a 120-year-old home and super insulated it, which is amazing for energy efficiency. When I moved into it, I didn't realize what this one device in the basement did. And we did get a little bit of mold like on a windowsill once. I'm like, what's going on with that? That's when I learned what the ERV in the basement does. And we had it unplugged. So this is an energy recovery ventilator. And basically it is in line with your ductwork system. And as it circulates air through the house, it basically is bringing in fresh air from outside. But as it's exhausting the older air out, it's basically going across a heat exchanger. And so the temperatures, end up being balanced out. So you're not just bringing cold air into the house, you're pre-warming that air with the air that's going out of the house. Plugging that back in made the whole difference. We did put in a dehumidifier in the basement, like a really, more than just the one off the shelf in the, from the Lowe's or something like that. It's a Sedona Sanadrive that we put in, and it's amazing. So we went from having a very, very wet basement, which was an issue before we even super insulated this house, to having a very dry basement, actually.
So can I follow up with that, Lindsay? Because somebody, Colt asked about how do you know if you're going to have a moisture problem? And really, there's one of two ways that I think that's going to happen. A, you already know you have a moisture problem. You're already running a dehumidifier. You already see, the river runs through it in the springtime during melt, or you have foundation walls that are buckling, obvious signs of hydrostatic pressure and permutation. You might see, if you're in a newer home, I've got some imagery in the case studies of the high water mark on the furnace. Usually most people know who have really high humidity that they have a problem. And then, insulation companies and energy audit companies who spend time looking at this ought to be in a position to know. If you want to do it yourself, by all means, buying a home, a moisture meter, a relative humidity hygrometer to put in your basement and monitor things is, they're pretty cheap. There you go. So you can keep track of it yourself. But as I said, most people who've been in a home for a while will know if they have a moisture problem. If you're not sure, lean on the expertise of a reliable insulation or audit company to help you. Mm-hmm. Ooh, there's a variety of questions here. Hold on. Just going back to the one prior to Colt's, Simbria asks, are the costs included in incentives and rebates?
So some of the energy, some things like some of the dehumidifiers can be covered through Empower, I believe, and it's home performance. So that's one place to have some help financially, because it's basically energy efficiency. That's part of the package. Generally, mold and asbestos and things like that are not currently allowed in the energy efficiency funding. That said, there is a there is some legislation in front of New York State right now that's considering, actually providing more incentives to help homes do this.
Right. So I hope everyone has access to the chat, because we have the honor and pleasure of having one of the state's most renowned building science professionals and energy audit professionals, Dick Kornbluth, respond. And so there's a lot of wisdom that Dick just pointed out actually in response. And I'll underscore what he's said. And actually, to respond to Colt's subsequent question, yes, an energy auditor ought to be able to tell you what's going on. I would be sure that you're using if you're using one of the NYSERDA programs, they will have the kinds of certifications that indicate they've had a training to assess what the relative humidity and moisture mitigation issues could be in a basement. It's always really important, particularly with steam boilers. I've been in old Victorians, and you have an uninsulated steam pipe running through this basement. The drying potential of that system is huge, and it can obscure often basement moisture issues. So yeah, hopefully, I will. So that's a conditional yes. They should be able to tell, but make sure you get an experienced auditor with the proper certifications. How's that? Contractor map, I hope to have up in the next month. Right now, I have a list I'm more than happy to send, but that's just for the 6 counties of the Mohawk Valley. I can work with Lindsay to help parse out the list for well, as Lindsay said, they have preferred contractors, so I think she would direct you to them.
Right. And so Bennett, Dick only wrote to us, so we should probably read what he wrote.
Oh, I'm sorry, didn't pay attention to that. Yeah.
That's okay. So Dick wrote, some moisture problems can be mitigated with improved ventilation, including heat recovery and energy recovery ventilators, like I mentioned mine. Also, the major driver for water vapor to enter exterior walls is air leakage. If the exterior walls are dense packed with insulation, such as blown in dense packed wood fiber cellulose, water vapor transmission and the ensuing damage to the wood structure will be reduced or prevented. So basically, in tightening up the home, you can actually reduce some of the moisture problems too. I know, one house I used to live in, we didn't have any air conditioning. We left the doors open during the summertime, and boy, did we have moisture problems in that basement, because all of that moist air went right down to the cold basement.
There you go. I'm just gonna roll through these, Lindsay. So the next one after the basement issues, Frank Price asks about whether or not he should or can leave his gas furnace and water heater in place as backup. Absolutely. There's nothing that says you got to pull it if you put a heat pump system in. Yep.
One of the things to know is there are also what they call dual fuel systems, where it's a cold climate air source heat pump paired with a gas furnace. So for people on gas, that is an option to look into. It's a one-way future-proofing your home. So, the air source heat pump could handle like all the way down to 15 degrees below 0 Fahrenheit, but then you can choose to use gas, just based on cost, and reduce the amount that you use over time. And at some point, we expect our gas system to become more or less obsolete. So this is one way of future-proofing your house.
So all these comments are the fact. I apologize. I did not realize that Dick's comments couldn't be seen or by everyone. So it looks like his comments not only did Lindsay read them, but they got posted into the chat as well. So people have a chance to look at that. I don't see anything else. Have we forgotten? Is there anything farther back that we missed? Anybody have any last minute?
There was one further back that was someone relating some challenges that they had with their particular air source heat pump system. And I want to just highlight, making sure you have really reputable installers doing the air source heat pump installations is important. Making sure that they know, the reputable ones are working in NYSERDA. They know how to do, the right, the right connections for the refrigerant. If the refrigerant leaks, it's one, it's bad for the climate. And two, it means that your system's not going to work real well. So you don't want your system leaking. So you want it installed correctly the first time. One other piece that they reflected that is important to know. So with cold climate air source heat pumps, there will be a time in the very cold parts of the winter where for a few minutes, it will actually seem like it's blowing cold air. And that's because it's going through a defrost cycle outside to keep it working well. It shouldn't blow it long enough to actually affect the temperature of your house. It just means if you go put your hand next to it, you're like, oh, that's cold. Don't stand next to it when it's doing that. It's the short answer. And you know, it'll soon do the little defrost. It'll be back to running normally, and it will keep heating your house. Cold climate air source heat pumps are designed to do that so that they work at those low temperatures.
I just want to take a chance to thank both Lindsay and Bennett for doing this. This was a great presentation and lots of great information. So I want to thank both of you. This has really been great. Thank you.
Thanks for the great turnout. It's wonderful to have a chance to talk this stuff. We loved it. We'll do it anytime.
Oh, Cynthia also wanted to know about mixed use properties. So basically the utility rebates are available for any building that's using less than, like the same residential size systems are basically available for any building that's using less than 300,000 BTU hours of, for their heating load. So it doesn't matter what the use is, whether it's residential, whether it's nonprofit, whether it's a commercial building, like you can install heat pumps in it and get the utility rebates at this point, which is nice. There's a lot of other programs available for various different types of buildings. Feel free to reach out to me or Bennett if you have a particular building in mind, and we can help you navigate what might be particularly available for yours.
I mean, the short answer to, can I just say, is that unfortunately mixed use is problematic actually in the eyes of NYSERDA, right? Because they fall into two different categories. So you end up having to split up how the various pieces. But
so it's not as straightforward as the short version.
We can help you navigate that.
Great.
Okay.
Well, thank you everyone for coming. Really appreciate. And yeah, spread the word, please.